Another thing you might want to find to help you graph or sketch or just another part of a quadratic equation that is often helpful are the x-intercepts. Now keep in mind, not every quadratic will cross the x-axis. So then we get to other types of answers and other types of solutions or x-intercepts that really aren't x-intercepts. We'll talk about that in a future chapter, but for now, we're going to mainly work with the ones that do cross the x-axis. And so in order for us to find the x-intercepts, we need to do one of two things. We either need to factor or use the quadratic formula. Factoring is great if the numbers are nice to work with. Quadratic formula always works. And if you don't remember the quadratic formula, just remember that x is equal to, that is the x value, these are solutions. We are finding x-intercepts. The way I remember, and I learned this like about 30 years ago at this point, is getting there. And I thought it was the silliest thing when I first learned it from my Algebra 2 teacher, but to this day I have not forgotten. And she told me that a negative boy couldn't decide on a radical party. The boy was a square, so he missed out on 4 awesome chicks. The party was over at 2 a.m. To this day, I thought that was the silliest thing, but I still remember the quadratic formula that way. I cannot think of the quadratic formula without reminding or remembering that statement. And of course, if you know the quadratic formula, then great. Negative b plus or minus square root b squared minus 4ac, all of that over 2a. There are several songs that can help you remember. However it is, if you know it, use it, because it is one of those that, well, will work. And so we look at an equation like negative x squared minus 4x plus 3, and we're like, okay, let's try to factor that. Two things that multiply to positive 3 and then add to negative 4, but wait a minute, it's a negative in front. So it's almost like we can just call that negative 3, multiplies to negative 3 and adds to negative 4. Try it as you might. This does not factor. So factoring here is out of the question. I have to use the quadratic formula. Conveniently though, we already got used to what a is equal to, b is equal to, and c is equal to by simply working with quadratics, right? So we have everything we need for the quadratic formula. So if you want to try to solve it, go ahead and pause. If not, I'm going to reveal what's behind the curtain. I plug those numbers in. And that's just a, b, and c plugging into the equation. Nothing too fancy. And then I start to simplify. So 4 squared, and then negative 4 times negative 1 times 3. On the bottom is 2 times negative 1. On the outside was negative negative 4, so plus 4. Clean that up, I end up with square root of 28. And that's how I know right away, hey, this thing did not factor because square root of 28 does not have a nice solution. And then remembering some of those rules from algebra where we had, okay, how do we go from 28 to 2 square roots of 7? Well, 28, square root of 28, you might call that square root of 4 times 7. And 4 has a perfect square, so 2 goes outside, 7 stays inside. Also, if you got used to doing this with the buddy system, where if you have all the prime factors, if you have 2 of a kind, then 1 goes out as a representative of the group. However you learn to simplify radicals, continue to do so. If not, I will show you the separating perfect squares that works pretty well. And so I end up with square root of 4, which is 2, comes out to the outside. 7 doesn't have a square root, stays inside. Clean this up. I got 4 and negative 2. So I can divide that out to be negative 2. I still have the plus or minus, and I don't have to revert that or reverse the order, because a positive divided by a negative is still going to give me one of each. And even if I have 2 negatives, I still get a positive. So it's still plus or minus, just the preference. We don't say minus or plus. And then, well, the 2's cancel for the second one. So my answers are negative 2 plus or minus square root of 7. There's 2 answers there, 1 plus, 1 minus. And for sake of graphing, we actually get some numbers for those. Keep in mind, this first set here, these are the exact answers. The second set here are the approximate answers. All right. So we only want to use those decimal answers for graphing purposes. All right. So it asks us to find the y-intercepts. So now we know where this graph crosses the x-axis, the x-intercepts. And we do that either by factoring or quadratic formula. If you can factor, great, because it's a lot less work. The last thing we take into account when it comes to a parabola is, again, the fact that it has a max or a min. Remember that it has a max or a min based on the vertex and based on whether it opens up or down. It is going to be a minimum, and that minimum is located at the x value of the vertex if a is greater than 0. That means that this thing is going to open up. So it makes sense if it opens up, it gets to a lowest point and comes right back. It's going to have a max. That means it's going to top out. Same exact thing at the vertex as long as a is less than or equal or less than a 0. Meaning that this thing is going to open down and it will have a highest point, a max. Then once you find that x value, you plug in to the equation to find a y value. That will be your max. X is where it happens, y is the max or the min. So the value that you get in return. So once you find the x value, plug in to find the y value. As I always like to end the lesson, the path of a baseball is given by f of x is equal to negative 0.0032 x squared plus x plus 3. Those of you that have taken physics or are in physics, you're going to get to a chapter that talks about projectile motion. That's anything that flies through the air. It follows the path of a parabola. That means that there's a given time during that flight that it's going to have an exact value on both sides that will be, in this case, because it's flying through the air, a height equal to, on both sides of its max or min. The question is, again, with a baseball, is this going to be a max or a min as it's flying through the air? It's going to be a max. It'd be super cool if I could throw a baseball, get to the bottom, and then bounce right back up without hitting the ground. Things that fly through the air will get to a max height and then come right back down. So this is going to be a max. How do we find the max? Well, the max is located at the vertex. And because a is, in fact, less than 0, this tops out. And at the vertex, negative b over 2a, we plug in some numbers. It's going to look weird at first. But oh, look at that. That's not too bad. And again, a lot of calculator work, especially with the negative 0.0032 times 2, then negative 1 divided by that. Oh, that's not too bad. So it's 156.25. And it didn't say. We'll assume this is feet. But this is where it's located on the x, away, 156 feet away. It does not tell you the max height. To find a max height, what do? We plug it in. We find the y value. Remember, y, vertical, by plugging in the x. Plug that into this really weird equation and then square it, right? It's just getting worse and worse, right? And then worse and worse, and then we add 3, right? The number's not too bad. So 156.25 feet away from the batter, assuming this was feet, it didn't exactly specify, but if we're talking baseball, that's logical. This thing is 81.125 feet high. So the max height of this baseball flying through the air is 81 feet. That's still pretty high up there. The last thing for this lesson is that sometimes you're given 2 points. One may be a vertex, and for the most part, one should be a vertex, although it's not necessary. But you're given 2 points, and you're asked to write the equation for a parabola that has, in this case, let's say, a vertex of 2 comma negative 5, and a point that's on the parabola of 0, negative 3. How do we write that equation? If we're looking at our given equation, we have a lot of information already known to us. We have y equals a parentheses x minus h squared plus k. We know everything we need to know in this situation except for one number. Can you guess what that number is, or which one of those letters is not represented here with a vertex and a point? H, K, X1, Y1. I don't see any reference to A. So I can use in my parabola those values of x1 and y1 in place of x and y to help me find the only thing I don't know, which is A. Now be very careful in simplifying this. 0 minus 2 is negative 2. Negative 2 squared is positive 4. Then negative 3, I didn't do anything, plus negative 5, I don't really need all that. Then I got to solve for A. I add 5 to both sides. I get 2 equals 4a, and then divide by 4. So a is equal to 1/2. So let's take a look at what I know now. I know that a equals 1/2. I know that h is equal to 2. And I know that k is equal to negative 5. When it comes to writing the equation the second time around, this time I don't replace x and y. This is for any new x and y values. So to write the equation, now we do not replace x and y in the final equation. I just needed to use them just for a minute so I can get the value for a. All right. So that brings us to the end of this lesson. If you have any questions, please don't hesitate to ask. There is a homework assignment. It will be posted for you on WebAssign. It is 7 through 12 all because it is a matching exercise. And then all the other ones, as usual, are odd answers that you can find in the back of your book. However, I do expect you to do this assignment on WebAssign so that you can get instant feedback and practice different versions of the same problem should you choose to do so. All right.